Hello my dear viewers, welcome to my channel PCM Guru Bro. Today we are going to discuss the physics NCERT text of class 12, chapter 3, which is dealing with current electricity, page 128, exercise question 3.11. Please like, share and subscribe my channel, please. And so the question starts right here. The question asks, by giving a diagram which is having a process of charging. The 8 volt battery is charged by a 120 volt DC charger, big battery, which is shown over here. No, this is a big battery which is to be charged, is a small one. So a circuit as a schematic diagram setup is drawn of this question, which is describing a 8 volt battery is charged with an internal resistance of 0.5 ohm, which is a storage battery, and which is using this 120 volt DC voltage, and why a series resistor is connected to it, having a resistance 15.5 ohm. First of all, they are asking you to find out what is the current in it and what is the purpose of this series resistor in it, and what is the terminal voltage of the battery during recharging, and what is the okay, these are the things which are to be found out. So yeah, as early in the classes which I have said in the previous PCM Guru Bro channel, the Kirchhoff's second law is applied to this circuit. This circuit has a big battery, DC voltage. The positive charge flows from here to this A, B, C, D section. Okay. And based on this big cell, I am taking A, B, C, D, A loop. What is this? Okay, I have first of all said based on this battery, then this should be given positive 120. Positive is facing another positive, so it should be given negative sign. So in line plus 120, against it minus 8 volt. Leave it. Then the other thing, on the way it is having I current, which is taken as negative, which is given convention simple minus I into the encountering resistance, internal resistance R, and then comes the next minus I into the next resistance, external resistance, big R. This is complete. This is the basic equation. So we want to make it easier. So okay, this is elucidated very clearly. 120 minus 8 is 112 volt, and this 112 volt is taken to the right side, minus 112 volt. This minus I is taken as common, 0.5 plus 15.5 is taken in bracket, so 15.5, 15 and a half plus half, that gives 16. 16 I is equal to 112. So this is much more simplified. 112 by 16 is 7 ampere. Then simply speaking, what is the purpose of this series resistor is that the whole current should not pass through this cell to make it damaged. So limiting the current to a desired value is the purpose of using a series resistor in the charging circuit. That's the base. And terminal voltage during the charging. What is that? Terminal voltage, what is this? Around the whole circuit, now terminal voltage across the resistance of the battery plus the EMF of the battery. That means the whole voltage, no, it is given as terminal voltage. So EMF of the battery we are given now, this simple 8 volt, that is given 8 volt. Plus the voltage across the internal resistance of the battery. No, that means there is a gap over here. No, that do also have a potential difference. That means which is encountering a small resistance R, which is given over here, and the current is passing through, that is 7 ampere. So the terminal potential difference is 8 voltage plus 7.5. That means 7, the half of 7 is 3.5. 8 plus 3.5 is 11.5 voltage. That is terminal potential difference. That is over. So the I current is found out, the terminal potential difference is found out, and the purpose of limiting the current to a desired value, which is the purpose of series resistor, is also found out. Now the discussion goes like this. For a competitive examination, this can be similarized to a a car battery when it is getting down now. We can similarize. So for this, a rechargeable car battery after a long time interval, battery is getting down. So the voltage is getting 12 volt, which is converted to 8 volt itself. The charge is reduced. So voltage is also reduced. And thus, the potential difference and I is not sufficient to make the starter work. So that is why the starter of the car does not work to make the car start. But when the 12 volt, that is nearly 11.5 volt, which is applied over here, no, not the full 11.5 volt, nearly, that is the rating of the car battery, which is applied over here, no, only by the use of this external resistance. So the needed current is got by the starter to start the engine. It means applying the necessary terminal voltage to reverse the electrochemical process. What is that? This is an electrochemical cell now. This is also an electrochemical cell. The needed electrons, no, will get eliminated after some time, which is used after some time, and then that electrons are replenished by this bigger voltage DC battery, and then the whole electrochemical process reverses. Thus, this lead acid battery is again reused, it is recharged. So the electrochemical process is reversed, and inside this lead acid cell, the earlier voltage 8 voltage, after charging it will get to 12 volt. So please share and subscribe and share my channel. I will come back with similar questions.